Okay, so I've been off for a while. I've had COVID, and I'm just going to get back into recording, hopefully regularly, and hopefully I won't burst into a coughing fit. So I'm just going to do. I was going to write some code, but I thought I'd record it. So here we go. What I'm going to do is the app I have on the App Store, which is very niche, don't I? It's called Readable, and you can find this. The website is readable.page, and it's on the App Store. And here it is running in the simulator. Now, it's really meant as an extension, so you can kind of. I've got a demo built in now, but you can drag an image of text onto this target area as well. But if you're in like something like Twitter or something, you can just long press on the text and an image of text. So it basically takes an image of text like this, and if you make it readable, you'll process it, turn it into something more readable which you can scroll through. So what I wanted to do is sometimes we get text that, let's just say the way it works. So the way it works is it detects the background color on this image, or does its best to decide what's background and what's text, and then it can kind of segment the text, and then it's able to process it. But that does cause problems because it's rather crude in determining what is the background color. Actually, does a sampling of the image to work it out, and it really falls down on certain images. So if I show this, like this, which has got multiple, quite often people post on Twitter things like this. The colour's not a problem because the colour's consistent, but what does cause it a problem is the highlighting, and highlighting is going to break it somewhat because it only really has an idea of what is the single background colour, not are there multiple background colours, and what is the text colour, and are there multiple text colours even. So I've got another image. So this, for example, this call out box here, it gets confused around, and then there's this piece down here where the text color has changed. Now, we understand that, but my algorithm currently has no idea of multiple background colors and call out boxes and stuff. So I wanted to essentially see if I could fix this problem first with this kind of text, and then see where that gets me. So I have my Readable project, and I have it open in Xcode. I'm going to put my glasses on so I can see. And I've got this preview app, and I've been trying out a few filters. So let's say if we want to filter it to monochrome, change to the preview, filter preview app. Can't see it. So if we run the filter preview, you can see it switched to monochrome there, and that's really nice actually. So I'm going to use that filter because it helps, like it's merged. Where am I don't know. Anyway, what I thought I'd do is, as you see, I don't really know what the solution is, but we're going to try a few things. First of all, I'm going to use my bitmap. So I represent the image as a bitmap of pixels, and I've got structs to represent them, and we've got this kind of Rec 709 Luma, which is essentially it takes the RGB and these scalars, all nicely hard coded, to create a kind of grayscale. So I'm actually creating my own grayscale. I'm not using this filter, this color monochrome filter, which is essentially if you look at core image, you can use the CI color monochrome, and I'm just putting in some standard inputs into it, and that does it. You know, let's have a look. There's crystallize, which is quite fun. I haven't put a menu on this because this really is a hack, but I should really. So that crystallizes it, and you can see that's quite, it's a cool effect. This is all done on GPU, should be anyway, because it's using core image filters, which essentially are GPU code. You can find the edges, so this is a good one. I really should put a menu on this. And there you go, that's pretty cool. It's found all the edges, pretty neat actually. I was surprised when I first saw how good this was, and it even finds the edges of my, you can just about see that there's a very faint blue, which actually shows the block of, there's preview. You can see the blue is actually this edge here, and it's managed to do that. So that's pretty interesting. So here's one potential solution, that I could use this edging, and if there's edges, detect them by following the lines somehow. So that's one potential solution. So I've been, fiddling around with these various filters, but so I've been fiddling around with those. What I want to try though is as part of the processing, I do go through every single pixel, which seems a bit of it's quite intensive and slow, and I want to be able to change the bitmap storage. So that at the moment it's essentially, if you look at this, it's just a block of memory. It's just a bunch of bytes, and it loads those bytes from the context. So it creates a context, loads the bytes, and then you can go essentially index into each byte, and you get so it's stored like this: alpha, red, green, blue, and that makes you can make a pixel out of that. So that's kind of how we're representing it. It's just a block of memory, and then we use this chroma to, if I can find it. This chroma representation, I think it's in pixel. Yeah, so when we create the pixel, and I know it's weird to have ARGB, but that's how it comes out of the memory, so I just left it like that. And what it's really doing is creating this value here. this monochrome value, and that's all we need to do. So, and we've got a red, blue, black, and transparent statics in case we need them, and so, and it's this value here that is the kind of monochrome value, which is going to be useful. And I wonder, and it's not quite the same as the way the filter was working, so this should give me a different colour for the different backgrounds, or more likely to anyway. So what I thought I'd do is I'd run length encode this to start off with, so that we're not just storing a load of, if I go here, this is one length, this is another, so, and then when you've got letters you've got lots of shorter broken up, so sort of a line which covers some text is going to be characterized by lots of run lengths, you know, one for each part of a letter and one for each gap in between. And we're going to and what characterizes just like a background, just pure background, is one run length, or in this case it will be 2 run lengths. So I'm thinking I can use the run length and the number of run lengths in each line to determine more information than I currently am, by just basically randomly sample. What I do is randomly sample and then decide which colour that I've sampled is the background colour and the cluster around that. So I'm hoping that if I run length encode it, I'll at least get some more information that might be more useful when I'm trying to break this into regions with different background colours. So that is my long-winded way of saying what I'm trying to do. So the first thing to do is to convert Bitmap, and I have no tests on this at the moment, so this is going to be a bit dodgy. We might write some tests on the way, you never know. And use, just basically give it a storage which we can, you know, with a protocol that we can kind of abstract away what the storage is, and then give ourselves some more functionality on top of that abstraction. So without further ado, let's try and write some code. So I'm going to make a new file, Swift obviously, get rid of this, done. I'm going to change our target to bitmap. By the way, I'm kind of following the 0.3 guys modularization technique, so I've got this package with all my modules. I broke it up the other day, which is how I've managed to break something, and I didn't bring over the tests. I didn't really have any, but because it's quite hard when you're doing this really low level stuff to think of a good test, but we're going to try. So we've got all of these feature modules plus a model, feature modules plus a models module, and then we have the app, the Readable app. It's just that. And that's why I really love this. And then we made a preview app which has got all the filters that we can play around with. So anyway, so in my bitmap module, I've got a new file. I'm going to call it bitmap storage. And let's start it off with a nice, I want a protocol. think I want a protocol. Okay, and it's going to have an index, I reckon. Seems like a reasonable thing to have. I think it's just going to be a get. What else do we want for it? We want an X and Y index. Yeah, that seems reasonable. That's public. So that's index is internal. Right. So we don't need that actually. Right. Anything else public, and we've got this get the Luma by sampling percentage. And there's a spelling mistake. Okay. So really, bitmap storage is going to have that public interface, and it also needs to be able to initialize. Don't need that because it decides, and we need to initialize it. Now, how do we go about that? Here's a initialize it with a CG image. Seems about right. And that's failable because we could just not work. Do we care? No, we don't. So we really want it to be made with a context. No, let's do it. Right. Get rid of that error. Import something. Subscript in. Oh yeah. We want to definitely do a get. Okay, so this is our storage. Then we can create something that obeys that protocol. And that could be Bitmap. So we could make it part of the protocol. Interesting. We've got these detected words, so I'm not sure I want. They're just a bunch of regions. What is this? Make words. Oh. looks like it should be part of that. Okay, my choice is to take the bitmap, make that obey the protocol, adopt, as they say, adopt the protocol, or make a struct which adopts the protocol that takes a bitmap as its implementation, and then we've got the kind of bitmap protocol that we can use. We can use a different kind of bitmap. As I'm trying to remove the memory out of this, I want to kind of have a storage class. Or struct really. Then we can have struct simple bitmap storage. And that's going to be adopting that protocol. Okay. And this will help us fill this in. And so from here, I'm going to grab this, draws it into the memory. So I'm just going to grab that, put that there, and we need do we need it? No, don't believe in it. And we've got these is in line and is in word things that we use for the make words functionality, which I want to take out of this. Don't care about that. Don't think I need to save that, and really all I need is the memory. So and then now we need the subscript code. This is public. This is pub. We're going to take these two. Bytes per row we need from the context. So I might just save off the context. Or the bytes per row. we're just going to pull up bytes per row rather than keep the whole context going. Right, so that's my simple bitmap storage. If I change my bitmap now to take a storage which follows the bitmap storage protocol, and instead of this we have storage okay. Static store properties are not allowed, so we're just going to leave that out. So we've taken out that. Might take out context. See what I need to do here. Just going to create storage equal to so we're going to attempt to make our storage, then we're going to self storage, set our storage, then we're going to fix any bugs we've got, compiler errors. So we don't need that subscript. Don't need context. I don't know if I need context. This should reach into the storage and didn't think I needed those arguments. Right. Here we've got this ModalLuma, which right. This is the current way of finding the background. I might just okay. I'm just gonna make it part of the interface for now. Go to my protocol, but I don't think I'm going to keep it. So git. I don't need to make it as a function. And then I'm going to take this. I'm going to add this to here. Now I need I'm just going to pass this in for now. Again, not totally happy. And then we're going to do so we do need to record, save CG image, which is fine, because that's easy to do. And I'll do that. Okay, so might still work. Let's just check it. A couple of errors. Yeah, so this is where I need an actual bitmap protocol. Replace those two bitmaps with a bitmap protocol. Let's see what we're missing. Hopefully it's not masses. Bitmap protocol's got ModalLuma, height, width, X and Y. Okay. So we need this. Right, and this is the make line. So this is the bit I want to sort of eventually replace, but we're going to give it a height and a width in the bitmap. It seems reasonable, I suppose. It's got to be a var. And we're going to give it a width as well. And we need a subscript, obviously. It's fair enough. Oops. And we're just going to be able to get. Okay, right. Here we're going to input simple bitmap storage. And here, right. Yeah. So in bitmap protocol, we might want this to actually take bitmap storage, but for now, bitmap needs to obey the bitmap protocol. Right, it doesn't, because we do have a width and a height. What else do we need? We need the subscript and the ModalLuma. Right. So our subscript is here. And what is this one? ModalLuma And that's going to call to storage. ModalLuma width times height percentage. One more error, hopefully the last one. Creating elements with a simplify. No, we don't want that, we want a protocol. Sorry. And where we were before, this should just be a so hopefully what's that done hopefully what that has done is separated out the idea of how the bitmap is stored from, you know, so we've got a different protocol for the storage to the bitmap, so that we can kind of swap out the storage to be the run length. You know, we've got the simple bitmap storage here, but we're going to try to make a run length encoded storage that obeys this protocol. And that, well, let's check it works, and then next episode we will swap in a run length encoder and see if we can keep it working, and then we can start maybe using that information. Fingers crossed. Oops. Memory. Okay. So that's interesting. Got bad access. We never allocate the memory. So how did I do that before? Before I drew into it. Data. Let's just see what's going on. So, have we got any data in our context? Hard to tell because it's an NS object type thing. It's got a width, it's got a height, it's got bytes per row. I think that should work. So now we've got some memory. Ooh. Only a single byte. Going to draw into that. Not convinced. Okay, well that's an interesting thing. I think I've uncovered a bug in the code. Surely. Okay, well I think I'm going to stop there. We've got a bug to fix. But that is going to take another episode, I reckon, to decide what the hell's going on. Determine, I mean, how come that, which is just this code that does work, doesn't work? And is it because I'm not holding the context? Might be because I'm letting go of the context. Yes, pretty certain it is actually. Yes, that's because we need the memory. I think we need the memory to stick around. So let's try it. If that's true, then we can it's not crashing so far. There we go. Okay, it was that. It's simple as that. Okay, the one small change I made was like, I don't think I need the context. I do need the context because the context holds onto the memory. So that's what we need that for. I'm going to put a little note on that. And I'm going to change the bytes per row. I wonder if I should be copying. So, just a little note to myself. Can't find where the minus sign is. Can't find it. To do copy memory. Okay. Well, that concludes this episode of live coding with me. So, just to recap, what we did is we can actually delete some code now, just to finish it off. Let's tidy it up. We moved the store, we separated the idea of the bitmap and how it's represented in memory out. And essentially introduced a new struct, a new protocol, as storage, so that we can create different types of storage which adopt the same, I don't know why I keep saying adopt the same protocol. Probably going to get rid of this at some point because it's really particular to this storage and the algorithm that we were using. But the idea is then the next stage is to create a run length encoded bitmap storage which has the same functionality, and we can just swap it in and out. Then start using it, and hopefully then we've got the additional information that we can use to replace this kind of the need to get the ModalLuma, which is basically what is the most popular pixel color, which is essentially is what when it's converted to a Luma, which gives us an idea of the background color, which obviously doesn't work if there's multiple background colors. So the point is that we probably want to get rid of this, but we're going to maintain it because it returns an optional anyway. We can just return nil in our new code, or just implement it differently whilst we figure out how to do the run length encoding and use the run lengths as additional information which we don't currently have easily available. Okay, so that's it. See you next time.